So, what can we do with the information we just got about mirrors? We can make images. Okay? So what I have here is I have an object some distance away from my mirror. Obviously, my object would be considerably bigger than my mirror, but for simplicity's sake, we're just going to treat it as such. This little dash right here is representing my focal point. What I'm going to do is ray trace. Okay? I'm going to trace out 3 rays. Okay? The first ray comes from the top and comes in parallel. Okay? Cool? So it comes in parallel. But any rays that come in parallel and strike a surface get rebounded back to the focal point. That's what we found when dealing with focal points, is that when an object comes in, strikes that surface, object comes in parallel and perpendicular to the surface at this point, it strikes and bounces right back out. Okay? The second thing is that when a ray comes in, goes through the focal point, it's going to bounce here and then come back out. Okay? Cool? And if you're having trouble seeing why that happens, do it in reverse. If a ray came in parallel, bang, it's got to go through the focal point and then hits the top of the tree. Okay? Or the arrow, I guess. I used to call them Christmas trees, but that's something we don't do anymore. Okay? So it goes in, bang, to that one to this point. Bang, to that one to this point. So it looks like we're getting all of these rays from the top of the tree to converge at this single point. Well, there's one more ray we're going to draw. So here's the first one. Comes in, strikes, does this. Now here's the third one. I'm going to draw it with a different color. It's a little harder to see. It's going to come in, it's going to strike the center. Okay? It strikes the center and comes back out with the exact same angle. Okay? So one ray comes in, strikes this, comes in parallel, goes through the focal point. Another ray goes in to the focal point, striking that point and then coming back out. And then another one goes bang, hits the center, and comes straight back out. Okay? So they're all converging at this one point. Okay? So what it turns out is that, first of all, this to the mirror here is called the object distance. Okay? That's my object distance. So it starts at the tree and it goes to the mirror. Okay? This, we've already called the focal point. We call this the focal length. Okay? So it's from the focal point to the mirror. That's called the focal length. And then this turns out looking like this is what we call the image distance. Okay? So it turns out when dealing with mirrors, or when dealing with this kind of mirror, we get 1 over the object plus 1 over the image. There's a plus in between here. There we go. It should show up. Is equal to 1 over the focal. Okay? So it turns out that we have this relationship. We have this relationship between object and image distance. If I know the object and I know the focal length, I know where the image is going to reappear. The other thing that's important about this reappearing image, it's a real image. If that image is created by real rays, like we do here, it's a real image. Okay? The other thing that's important is to know what magnification is. Okay? Magnification. How much is that image magnified by? Okay? That's over object. Okay? So image over object, and there's a negative sign here. Okay? Negative image over object. The negative simply is there to invert the image. So it starts like this. So when it reappears on the other side, it's inverted. Cool? So we got this equation, 1 over object plus 1 over image equals 1 over focal length. And then we have this equation, m is equal to negative image animation. How much bigger does that image look like? So if this image turned out to be 2 centimeters and my magnification is 1/2, then the object's going to turn a centimeter. So you take that 1/2, you multiply it by the original image, and you get the new image, the magnified image. In this case, the magnification makes it smaller. Okay? Cool? So that is a concave mirror. Let's talk about convex mirrors next.